All right. All right. What I need you to do is when I'm start talking, everybody need to be quiet. But so sometimes I will tell you I'm in a bad mood, and yeah, if I'm in a bad mood, then I'll be very real, like I'll be very crazy. But if I'm like super tired, I will be really in bad mood. So if I'm talking, just learn to shut up. Um, if you don't, I think happened recently. I told a kid to shut the f up because I was just in a piss off mode that day, and I got investigation and whatever. But yeah. So don't mess with me when I'm in a bad day. Today I'm not in a bad day, so. But I'm gonna put a chart on the top says today how's my day, so you know not to mess with me if I'm in a bad day. In the past, I throw a water bottle at the kids. Um, huh?
Like a plastic one?
Yeah. Some people know what happened, right? I threw a desk before too. That's funny. I don't want to trash talk there, but I'm gonna hold back. Um, I'm gonna hold back because that's kind of funny. But anyway, no, I did do that once. Is because people doing I teach this class in the summer school, and the average GPA in that class is about 1.3, and so all the kids failed algebra not only once, they failed 3 times. So they take the paper and they chew that small thing, and they put in a straw, and and I was writing on the board, and all I think is spitball coming to stick on my board. I turn around, I pick up a desk and throw it across the room, land on the wall, hit the wall, and bounce it off. And since that day, nobody ever messed with me. But
That's the same trap house as the kids, right?
yeah. Yo,
Do they also wear like woven sports jerseys?
no.
Sports jackets?
That's about 10 years ago. And but the funny thing is, not a single person failed that class. Everybody passed the ELC. Every single person passed the ELC. At that year, there was a quarterback who cannot cannot play football, because every time he bring his mom to come in to say thanks to me, every single year after that, because he was sophomore and he cannot play football because he was a very good quarterback too. He cannot play football because he failed algebra 1 3 times, and every time like he will bring his mom to my room and say, "Hey, look, this is somebody changed my life." Now, I will tell you, like, I'm not in a good mood. I would do a lot of crazy things, so I just give you a warning. I don't think anybody ever see me last year do crazy thing, but I have done crazy thing before. I threw a basketball at a kid. I threw a desk. Um, I'm not proud of it. I'm not saying I'm proud of it, but I'm just gonna tell you, if you piss me off in the wrong day, then that's probably bad. But don't. Yeah, I'll put a chart of Mr. Yes
Bad days.
bad days.
History of bad days. They get a calendar so we can start tracking it.
Yeah.
Tracking your comments, your motorcycle.
Yeah. Men can go through different situation too. All right. So, for this particular part, we want to talk about concavity. Yeah. So I'm start talking. Just let me talk because I don't want it to. get mad at you. Concavity, there is a concave up, and there's concave down. But people think it's a smile face or sad face from Ollie's or Ken's class. I don't define that way. So in my class, I actually define as like a Karate Kid thing. But I will show you tomorrow because that's gonna involve it tomorrow. So what happened is you have a concave up like this. We all know this concave up is a concave up. Is actually mathematic way to define that concave up is when you have a tangent line. So imagine if I draw a tangent line on a green dot. Is it gonna be below the red line or gonna be above the red line if I draw a tangent line? Below, good job. It is below. Do you see that? That's below. And if you take this point, it's also gonna be below. If you take this point, it's also gonna be below. So it doesn't matter what. If your tangent lines are below the curve, then you are concave up. Now this is different in smile face and different thing because in calculus we do have situation happen differently. So if I have something like this, and if I draw a random tangent line, guess what? My tangent line is above now, so it's concave down. If you see this is concave down, this is concave down because my tangent line is above. Because later on, they're gonna ask the question this way. They will say, hey, is your tangent line is over approximation or under approximation? If you see that visually, you're able to determine that justification. Easy point. You don't need to do math on the FRQ. So make sure you understand the true definition. If a tangent line is below, you're concave up. If tangent line is above, then you're concave down. That's a correct way to define something. Yeah, you can look at the drawing. It's probably better to see drawing. Tomorrow I'm gonna show you a movie clip from Karate Kid. Yes. All right. So now what you're gonna do is you're gonna actually says, well, how do I find a concavity? Now, not a little bit different than pre-calc. Pre-calc will give you a graph. We're gonna ask you which part is concave but which part is concave down. But in this particular case, we're gonna say f double prime of x is greater than 0, then is equal to concave up. So you need to do a number line test on second derivative. If you do this less than 0, is equal to concave down. And if you see f double prime of x change from positive to negative or negative to positive at x equal to c, then c comma f of c is relative, it's inflection point, sorry. It's an inflection point. So that's pretty much everything's today's notes. Huh? Nelly asks question, says, what if what equal to 0? Oh, the second prime? Okay, if the double prime equal to 0, it does not mean anything. It just means the possible inflection point. Because you could have changing from positive to positive, right? Even you go positive, 0, positive, right? So if it's positive, 0, positive, it's just the possible inflection point. So, but if they change in sign, that's an inflection point. Okay. So if you want to find a candidate of inflection point, you set the second derivative equal to 0. Is that okay? So now I'm going to give you a question. I'm going to ask you to take a first and second derivative. So this one is f of x equal to 6 over x squared plus 3. I want you to take a first derivative. I want you to take a second derivative. Now I want you to check with each other what kind of derivative they got before you go to the next one, because you don't want to make mistake and go into the next derivative. I also told you, like, the reason why I get mad is because I don't actually take a day off in school. So when I'm really tired, other teacher will take a day off, like mental health day. I don't believe in mental health. So I will show up the next day. I'll still be here. But yeah, just make sure when I'm speaking and you guys be quiet. So that means I have something important to teach.
X squared plus. Oh, I'm not there yet.
Your first derivative must be correct before you go on the second derivative. So you gotta verify your friend says, hey, what's your first derivative? Make sure it's on the same track before you go to the next one. Now, I won't personally do quotient rule just because it's a constant on the top. You can choose whatever you want to do, but I won't do quotient rule because I will always choose the fastest path to do something. Do you guys do chain rule? Is this okay? Okay, now I'm going to the second derivative. The second derivative, I will stick with the quotient rule. Some people do prefer to do product rule. I think that's unnecessary. I think this unless situation, I will do quotient rule. But I will factor out GCF though, because something can cancel with the bottom. So those are the things that you gotta be able to do. So second prime, Okay, low, D high, minus high, D low, over low low. Do you guys get that? Did you guys forget 2x? Anybody forgot a 2x? Make sure you always do the chain rule. Liam, do you know how to do this? You got this part right? What is -2? Oh, it's not -2 because you are thinking about low. So just take the derivative of this. That's it. Don't worry about moving to the up. If you do product rule, then you got negative. So I will factor out this x squared plus 3 and x squared plus 3 because x squared plus 3 to the first. Once I factor out, I'm gonna get. Oh, I'm actually gonna factor out 12 as well because I think they both have 12. And if I factor out, I have left is a negative sign on the first one. And that's going to be x squared plus 3. Does that make sense? Now, this both negative change it to positive. So I factor out 12. So I have this left, I have this left, and I have this left. So it's going to be plus 4x squared. Is that okay? All over x squared plus 3 to the 4th power. Now, if you realize this can simplify down 3, and that's equal to 12 times 3x squared minus 3 all over x squared plus 3 to the 3rd. I even factor out 3, 36 over x squared minus 1 over x squared plus 3 to the 3rd. Now, if you realize, does a critical number happen on the bottom? No, because x squared plus 3, right? So then I would do x squared equal to 1, x equal to -1, and x equal to positive 1. Now I will do a number line test between -1 and 1. And I'll have 36x squared minus 1. I have x squared plus 3 to the 3rd. This is all positive, doesn't matter what. This is one that is going to be positive, negative, positive. So positive, negative, positive. This is up. This is down. This is up. So therefore, I find everything on this thing. The hardest part is if you can take a derivative correctly, factor out the right thing, simplify the right way. Make sure you do the right thing.